Hello, hello, hello. Hopefully my voice is working. Welcome to my latest live stream. This is live stream number 23, and we're going to continue working through the Boeing Starliner case study. We're going to be talking about all things space, all things NASA, all things Boeing, and of course I'm going to be talking about things through the lens of STAMP, STPA hazard analysis, and cast accident analysis. So welcome, my name's Simon Whiteley. I'm a systems safety engineering consultant and accident analysis consultant based in the UK, and I provide support to mainly aerospace and defence organisations, but also healthcare, railway organisations in their journey learning about what STAMP is and how it works, and then of course the methods based upon STAMP called STPA hazard analysis and cast accident analysis. And if you're interested in that topic, then this live stream is for you. So please, you're most welcome to send me messages, type in the chat, whether you're watching this on LinkedIn or YouTube or Facebook. You're welcome to send me some messages, tell me where you're watching from so I know that you can hear me and it's all working. And then, of course, if you've got any questions about any of the things that we're going to talk about today or the past live streams, because obviously this is number 23 now, so there's been a previous 22 that you've probably watched or had experience with. So, of course, if you've got any questions, please tell me what they are. And, of course, if you've got any experience you'd like to share, please feel free to do that. It'd be fantastic to learn from you as well. It's not just a one-way broadcast. If you do have something you want to share, please get in the chat and let me know what it is. Now, you may be aware that my intentions with this case study is essentially to share the learning and experience with STAMP through the lens. I can't speak today. I'm going to share the experience of STAMP in the context of space, but the main intention is to, once I've got through this case study, I'm going to run a live workshop, a complimentary case study workshop, where we can get together live in a Zoom room, on camera, on microphone, and we can talk about this experience live. And of course, you can ask your questions live, and it's in a small community, small group, and it is a free session. It is a complimentary session, because my objective is to educate and make people aware as much as possible about these methods, and help them in their journey trying to get some results with it. So please visit my website. If you go to whiteley-safety.co.uk, you can, if you need some help, you can send me a message. So click this button, I need help now. You can stick your name and email address in the contact form, and I can set up a conversation and answer any questions you've got. Because of course, for me personally, it's, I've got a lot of experience from over the years, and something I can answer in 5 minutes might take you, say 6 months of banging your head against the wall. And of course, that's essentially 6 months of opportunity lost. So if you do have any questions, please don't hesitate to get in touch, and we'll have a conversation and see how I can possibly help you, get you unstuck, get you moving again, or if you need some serious help and support, then we can discuss that. And of course, also, let me just move over here a bit. There's the link to the free workshop, so you can click that button, join the waiting list. And of course, when I finish going through the case study and I've put my slides and everything together, I'll send an email out to the wait list and get everybody involved, set a date and get us involved. And of course, if you would like a foundation training, I do have a compact one-day foundation training available, which is accessible from anywhere in the world with an internet connection. And if you click on that button, you can join the wait list for the next dates I'm going to release for that course as well. So here we go. Let's get stuck into our case study then. So where we got up to yesterday is we completed section 6, root causes. So we talked about that at length. And now we're going to go into section 7, And then depending how much time we got, then we might also get through some of the consolidated recommendations. But let's focus on section 7. There we go. Let's get down here. There we go. So we did section 6 yesterday, root causes. We talked quite a lot about the concept of root causes and how that's slightly different and complementary in some ways to how we define causes of accidents in STAMP. Because the fundamental principle of the STAMP accident causality model is that all accidents, any accidents, are due to inadequate control of some shape or form. And so if I was being really facetious, I would say there is only one, that's 11, that's 2, one true root cause, and that is that the control structure is inadequate in some shape or form. And so our mission is to either, understand what the control structure is and prevent it from being, inadequate in the future, or if we're trying to design our system, if we're trying to change our system, modify our system, of course, we want to anticipate the hazards, anticipate what the necessary control structure is to either eliminate or manage those hazards or manage the consequences, respond and recover from those consequences. So that's fantastic. Okay, right. Let's keep going then. Let's keep going. So additional observations then. So this is only sort of 4 or 5 pages, so we should be relatively quick through this. So additional observations from the investigation team. Yes. Observation 1. No clear criteria for Starliner. There is no clear objective for utilising Starliner 1 in returning to crewed flight. I'm not quite sure I understand what that's getting at. I could interpret that in a couple of different ways. Recommendation. Crew commercial program and Boeing return to crewed flight. Create disposition criteria for returning to crewed flight. Okay, so in the aftermath of this accident, I'm getting an impression that they just said, no, we're not going for crewed flight yet. There's things we need to do. And I think this recommendation is just basically recognising that and saying, well, look, before you go flying again, there's some things you need to do, and this is one of them. So create disposition criteria for returning crewed flight. Include, but not limited to, the top-level objectives for Starliner 1 and future tests that must be completed to sufficiently reduce the risk to the crew. A detailed listing of all configuration differences between CFT, Starliner 1 and Starliner 2, and clear risk justification if deltas are identified. Yeah, I mean, this just to put a fine point on things. So when you're thinking about things through the lens of a control structure model, it's important also to consider the configuration of parts of that control structure. So in this case, it's relatively straightforward. You have a product, service, or system. In this case, we've got a Starliner spacecraft, and then around that, the context of that, you have an operations organization. You'll have a response and recovery organization, perhaps. You will have logically a design, development, test, and qualification organization. You will also have similar for the training, recruitment, retention, and replacement of key crew members, key personnel. The selection and training of those key personnel. But when we're thinking about the spacecraft itself, the specific tail number, so to speak, they will have different configurations, especially during a test program such as this. I mean, one of the test programs I was involved in, 20 years ago now, I get proper old, on the Royal Air Force Nimrod MRA4 program with BAE Systems. So they had 3 flight test aircraft that were, of different vintages. Of course, they look very similar to the untrained eye, but the actual makeup of those 3 aircraft and the types of flight tests that they were going to perform were very, very different. So you have a flight test organization control structure, so to speak, and how they configure the aircraft or the different tail numbers, the different spacecraft in this case, and of course the limitations, because some of them might not have certain equipment fitted. Maybe they don't have qualified. They might have safety equipment fitted, but it's not qualified for use yet. And so they have, envelope expansions. They have qualification tests that need to be done. They have to do the tests, collect the evidence, assess the evidence, and then make decisions. And some of those decisions might be, you can't use that system. We need to make some modifications to it. So, operating a complex system is very complex. But when you're trying to design, develop, and test these things, it is just mind-bendingly complex. And I'm not sure most people really appreciate that unless you're involved in those kind of activities. It is really, really complex. And so having an appreciation for what those different control structures look like and how they interact, is a real advantage to really making things safe and also setting objectives. I mean, we've been talking about top level objectives for Starliner 1 and first tests. We could use STAMP and STPA to help us define those objectives and how those objectives can be achieved and the necessary feedback and the types of decisions that need to be made. So yeah, I mean, and configuration control. So one of the jobs I had over 20 years ago now, working with Rolls-Royce, I was a configuration control engineer at one point. And I didn't know what configuration control engineering was until I worked with Rolls-Royce and started to understand how complex it is to manage the configuration of jet engines. All the different components, the parts, the build standards, the modification standards, all of that good stuff. So then doing a configuration control engineer's job, I really got an appreciation for how important it is. For some people, it might seem like a bit of a boring, a bit of a, oh, well, that's kind of, a bit too detailed. I'm not really interested in that. But when you actually start to look into how important it is to configuration control, not just parts and components and build standards, but also information, making sure the right information in the right documentation goes with the right tail number or engine number, so to speak. So it's organizational data, technical data, operational data, the equipment themselves, the build standards, the modification standards, whether there's any variances, because often there are technical or administrative or documentational variances, deltas. I think it mentions here. There we go, deltas. So it all requires controlling with a control structure, both administrative and technical. So yeah, if you want to blow your brains out with how complex it is, that's just a hint. And of course, we're human beings. We have our own human factors and behaviours, and it is very challenging to manage that level of complexity in our heads. So having a control structure model to hand can help us to manage that complexity and that anxiety, that angst, if you like. So re-examination of all crewed flight test objectives, FTOs, that were not met or are only partially met on crew flight test, and determine if these will be met on Starliner 1 or in other ways prior to Starliner 2. Yeah, I mean, this is a hugely important requirement, because it seems that these objectives and the achievement of them, whether that was not met or partially met, was one of the challenges prior to getting to do the first crew flight test. And so the organisation that's involved with setting objectives and agreeing when things are not met or partially met to continue, that is an absolutely fundamental part that this investigation should go and look at. Because it's not, just the technical issues with the spacecraft. There are a lot of organisational issues with the flight test organisation, the way decisions are made, or the way information is passed around the control structure. Okay, so define qualification envelope. So this is more specific. This is about the service module propulsion system and the command module propulsion reaction control system. Show tested range and operational range for critical parameters, e.g. inlet valve temperature, mixture ratio, duty cycle, etc. So there's two things here. The first is, who or what is the controller that defines the qualification envelope for those two modules, those two aspects of the spacecraft? And then, of course, the design of the spacecraft and the flight data, the test data, the flight data, the instrumentation. How do we define or document the tested range, the operational range? How do we check, the delta between the two? What meaningful feedback does the test organization need for qualification versus what does the crew and ground control need for the safe operation of the spacecraft? And then, of course, what do the investigators need? So if you need to investigate anomalies or an accident or whatever it is, what feedback, evidence, information, and to what level of integrity do the investigators need? So again, the control structure, the control loop concept from STAMP can really help supercharge getting clarity on exactly what is needed, and then decisions can be made with clear information, what they can live with, what they absolutely cannot live without. Identification of any new or critical FTOs. FTO, everybody. Is it a flight test anomaly or something? No, it's not. What's an FTO? Come on, everybody. It's not in the list. Of course it's not. FTO. Flight test. Oh no, hang on. It's on the page above, isn't it? Flight test objectives. There it is. One day these acronyms might actually stick in my brain. Here we go. Look, flight test objectives. FTO. Is that right? Yes, it is. There we go, Simon. Well done, mate. There we go. Stick that in there. Right. So, identification of any new critical flight test objectives that must be achieved on Starliner 1. This is fantastic. STPA could absolutely help with that as well. And I think if you've watched some of the other live streams so far, you'll be like, Simon, your common theme is STPA could help everywhere. And I suppose the short answer is yes, it could. But of course, there's different contexts, and they will overlap, and there'll be interactions between those STPA application activities, and of course they'll need to be coordinated, because you don't want to be doing the same work over and over again. You want to make sure you're not repeating yourself and all that kind of stuff. Okay, so Starliner 1 should be utilised to obtain necessary data to ensure there is a reduction in risk for future Starliner missions. I agree with that. Kind of goes without saying. Reductions in risk, including validating the new Therm 11C model with Starliner 1 data, validating guidance, navigation, and control firings for RCS thrusters, and validating thrusters, RCS thruster performance during key phases of flight. Yeah, I mean, I probably suggest you don't want to do that with people on board. You should probably do that, uncrewed. Pardon me. Let me just have a drink. Bear with me. Okay, so observation 2. Starliner longevity, mission suitability. Hardware and launch vehicle availability raise longevity concerns for current and future programs. That's a supply chain issue and a launch coordination control structure issue. And those kind of issues are always going to exist unless you invest in making sure it's managed properly. There's enough resources for it. As noted by the STAR report, so that's further down in this investigation report in the appendices, appendix, whatever it is, H or whatever. Starliner has limited hardware spare availability. This is a concern for being able to complete remaining flights to ISS due to limited life nature of some components and ability to replace critical components when failures occur or utilising hardware for testing. So I'm going to just quickly go on a detour about this, because this is a really subtle but really important topic. What does the control structure look like for dealing with this? Hardware availability, spares management. What about repairs? What about modifications or making sure that there's enough parts in the supply chain? Who or what is that controller? How does that work? How is it prioritized? What decisions is it making? Is it that the supply chain, is it that the spares availability controller, for want of a better description, are they making decisions based on cost of the program, or are they making decisions based on successful missions and the overall success of the program? So cost versus success. Who is making that decision? Who is turning the dials? What control actions they're making? What feedback are they getting? How carefully are they being controlled? Because I think we touched on this yesterday or on Tuesday, not yesterday, Wednesday or Tuesday, live streams 21, 22. It's important to make sure that they're coordinated and that they're making decisions for the benefit of the program, not necessarily their own individual benefits, their own short-sighted view of things. Because you can have lots of controllers all over the place looking after their own train sets, and they're optimizing for what's right for them. And simplistically, you could say, well, they're just doing their job. It's a dangerous success. They're doing what they're supposed to do. If there isn't an overall coordination function going on, you can be having everybody perfectly optimized for what their goals are, but then it's undermining everybody else and tripping, the overall program up. So that coordination, that refereeing needs to happen. And what does that look like? How is that done today? How should it be done tomorrow to make sure we achieve those big program level goals? A long-term use of Starliner requires a launch vehicle transition. If Starliner is to continue to provide access to low Earth orbit for humans, this will something it require moving Starliner off Atlas V and onto another launch vehicle, as the Atlas V is phased out by the United Launch Alliance. I think that is ULA. So again, there should be a control structure looking after that exact exam question. What is it about the requirements and the interface of Starliner is necessary for Atlas V, and how could that, does that change for another launch vehicle? And what are the options for another launch vehicle? Are there any options? Is it SpaceX or whoever? It almost doesn't matter. But there should be a team, I imagine there is a team that's specifically looking at the exact exam question. So how could they be empowered by using STAMP and STPA? That would certainly, I think, help to lead them in the right direction. Recommendation then, so 57. CCP SOMD, longevity of Starliner. Crew commercial program, evaluate capability shortfalls with hardware sparing of blankety blank, blankety blank. Assess ability of Starliner to fulfill contracted missions to ISS. Identify associated technical work to be completed by CCP Boeing, and where gaps exist, implement an action plan to appropriately invest in the Starliner vehicle for the remainder of ISS missions. Again, who or what is the controller in charge of that activity? What decisions do they need to make? What beliefs, mental models do they have? What feedback do they need? And also what control actions are they providing and how might they be unsafe? SOMD, evaluate long-term capability shortfalls, overall human rating, and sparing for Starliner missions in CLDP. What's CLDP, everybody? Pardon me. CLDP. Starliner, yeah, okay. CLDP, it's only mentioned twice. That's handy. Fantastic. It's not in the acronym list. Okay. Crew launch development program, I don't know. Identify associated technical work to be completed by CCP Boeing where gaps exist, and implement an action plan to appropriately invest in the Starliner vehicle to reduce risks for future crewed missions. So I would suggest, because obviously I'm biased, based on these live streams, that the SOMD, and I can't remember what that is, I'll figure that out in a second, they should recommend or they should mandate the use of STAMP and STPA. Because I think that would seriously benefit and supercharge getting back into space and delivering on the contract, and do it in a safer, maybe even a cheaper, quicker way of doing it as well. You can't always rule that out, because when people get good using STAMP, they get really good really fast, and they can start making real impacts really quickly. But of course, the organisation has to be prepared for those kind of results, and it requires a certain level of openness that this investigation report seems to imply. The culture is a bit challenging, and efforts need to be made to recover that and sort it out. Fantastic. As noted by the Star report and Pitt interviews, Starliner has limited hardware spare availability. This is a concern for being able to complete remaining flights to ISS due to limited life nature of some components and ability to replace critical components when failures occur, or utilising hardware for testing. Have I not already read that? I'm sure it says that twice. Oh yeah, it does. Yeah, it's the same. It's the same copy and paste as that bit there. Which is fine. It's not a big deal at all. It's just, as a reader, it does get a bit boring reading the same over and over again. Anyway, observation number 3. Here we go. Root cause analysis as an activity. Knowledge and skills are a critical skill tool in conducting thorough and complete investigations. I completely agree with that. The availability of skilled personnel to lead a team through this process is limited, and skilled personnel educated in RCA should be retained to conduct thorough investigations. I absolutely agree with that, but I would go further and say STAMP and cast accident analysis. And, you know, I could help with that. I could seriously help with that. I could train your teams up to be able to use cast accident analysis successfully. I could help them to develop skills using STPA, so they could make recommendations that are very specific, technical or organizational, human, and of course be able to assess systems so that they can see whether there are any issues with those architectures, those designs. That's something I've done a lot, and have various colleagues with a lot of experience, very serious authority to get involved and help with that. So if you want help with observation 3, please send me a message. If you need, like I said before, if you need me to get on a plane in the middle of the night because it's that serious, I'm prepared to do that. Send me a message. Let's have a conversation. If you need everybody training and supporting in this, coaching, mentoring, facilitation, I provide those services. These unique and specific skill includes capability to create detailed fault trees. Yeah, I think that's not really that helpful. I think that's, yeah, you can do it, but it's a bit of a distraction. An STPA control structure model would be far more useful than that, I think. But again, this is a traditional approach. I'm not saying we should throw it out and not use it. We can use it, but I don't think that should be the be all and end all. And I'm hoping, based on watching some of these videos, if not all of them, you will get that same conclusion as well. Yes, let people who do fault trees, but let's do some STPA, let's do some cast, and then we can compare the results and do an assessment of the benefits of both. I'm not suggesting you throw away fault trees or RCA, but there is so much more you could do, so much better. Please comment below, let me know your thoughts. Including necessary software capabilities, the ability to distill technical designs into fault tree nodes, and deep enough understanding to lead a team through the process. See, the thing is, with building a control structure model, once you understand the principles of how to build them, people who don't necessarily know the technical detail can facilitate the creation of some really good models and get to some really detailed, difficult questions that are not intuitive, you wouldn't normally think to ask. I mean, the number of times people have said to me, Simon, how the hell did you know that? And often it's followed up with, and that's classified. How did you know that? And it's because this method, the systematic approach it has, the principles it has, it enables you to really start to unlock, the detail of these designs and identify potential causal scenarios to consider. So as long as you've got a skilled facilitator, you could go really far. And if you have a skilled facilitator and somebody who's inexperienced in all of these things, then they are absolute rocking horse. If you find some of those, you need to get a hold of them and look after them. This includes organisation of a justification and justification of fault-tree box closures to generate proximate cause, followed by the development of causal factor trees and or follow-on questions for interviews to get to root cause. This may include 5 whys, yay 5 whys everybody, method, causal factor trees or other appropriate tools. Retention of these skills should be deliberately trained for retention. Fantastic. I like the sound of that. When it says or other appropriate tools, I think that's where we should stick STPA in there and cast. So I'm just going to get my pencil. Let's see if it works. Look, it works. Look at that. Other appropriate tools. Stamp. STPA, hazard analysis, plus cast. And even then, it's not necessary to go to town and do all of those in detail. You can just use the basic concepts of a control loop, which is this jigsaw piece that I keep showing to everybody, and I'm hoping it's drilled into your brains by now, and a control structure model. There we go. My handwriting's not very good on here. And then the other element is the concept of control actions. And if you want to go really far, there is loss, control action not provided. Provided, control action is provided with specific context. And then there are timing, duration, and sequence to think about. And they break down into timing early and late, duration is short and long, and sequence is specific. Like I said the other day, if you're talking about a specific set of control actions or a control action which is a compound of other elements, such as ready, aim, fire, the sequence of those could be quite important, So yeah, that's fantastic. So I suppose other appropriate tools, that does leave the door open for others to consider using Stamp, STPA and Cast. And that's the purpose of all these live streams, to just demonstrate that value. So yeah, I'll just put a, oops, excuse me, I didn't mean to bang the microphone there. Sorry to all the headphone users. I didn't mean to wake you up. There we go. Okay, recommendation. Let's get it. Number 58. We've got OSMA. Assign root cause analysis investigation skill as a required skill set to be maintained and retained within the context of human spaceflight investigations of all types. So yeah, I would suggest expanding upon that and making Stamp, STPA and particularly Cast in that as well, not just RCA, because I'm hoping you're going to see when we start going through the RCA report in the next couple of live streams, you're going to be like, wow, how did you find all of those gaps? How did you get to that specific question so quickly using Stamp? So I'm hoping I'm going to be able to demonstrate why that is the case. Well, I'm not hoping. I'm confident I'm going to demonstrate that. And I hope you stick around and watch that. Okay, of all type, regardless of classification or specific process called upon for reuse, require SMA to build up the required skill set through training and benchmarking with a and develop a retention plan. This skill set can then be utilized by all NASA programs for various levels of anomaly investigation. Yeah, fantastic. I think that's a great idea. But just don't focus on RCA. Expand it to include STAMP, STPA, and CAST. An STPA sec, if you want to get involved in cybersecurity stuff, I'd recommend that. There was an incident I've seen reported on Twitter. I haven't dug into it to understand the detail of it or whether it's just misinformation, clickbait nonsense. But there was a Russian, I think it's an Su-57 aircraft shot down in Moscow or over Moscow, and apparently it was friendly fire. And there's a news reports or little tweets come out that apparently the Ukrainian security services or military have essentially hacked into the into the air defense system in Moscow, and which led to the operator to believe that this was a hostile aircraft when it was a friendly, and so they engaged it and shot it down. I don't know the state of the crew, whether they survived or not. Probably not, depending upon what defense system it was. But from a STPA and an STPA cybersecurity perspective, they're the kind of things that we should also be looking at. We all should be thinking about, are there any potential adversaries or hostiles that are trying to interfere with our systems, with our success? And we should really consider that. An STPA set can certainly help with that. And I can name a few experts in those fields if you want help and support specifically for that. And I also have colleagues that can help from a more specialist security perspective, but I'm not going to share details about that today. If you want to talk about that, please let's have a conversation. Okay, observation number 4. Serving as a member of a root cause investigation team should start with training on investigation tools used and agency capabilities to utilize to complete a thorough investigation. So a root cause investigation team. First thing I'd do is change that title because, we're looking for a root cause, are we? Oh, there is a root cause. Yeah, I know it sounds a bit pedantic, but labels for things can really change the way people perceive what it is and what they're trying to do and the things that they look for. And an example, if you're driving your car and you're at a T-junction ready to pull out, if in your brain you're subconsciously focused on looking for cars, when there's a motorcyclist coming down the road, quite happily, merrily, and then you pull out on them, is it because you were thinking about cars or vehicles and not motorcycles or cyclists? The human brain is very, very advanced, very energy efficient, and sometimes we can be our own worst enemy and it can result in some negative consequences. So just be mindful about these labels. And let's choose something a bit more helpful for everybody involved. Okay, recommendation OSMA for program investigations governed by OAWI007. Let's find out what that is, everybody. And I'll not do a live Google search because you never know what might come up and I don't want to get banned. So hang on, NASA procedure, is it? Oh, right, okay. So OAII007 is the internal review team established to investigate this thing. So I think that's that is the what do they call it? I think that's the actual letter that describes how this investigation is supposed to be conducted. Let's just look at the table of contents. I think it's one of the appendices. Maybe it's the last page or something like that. Oh, there we go. Investigation Team Chartering Memo, page 201. So let's just jump all the way down here. Page 201 is not there. That's 301. 284. No, it's not that. Come on, 201. Where is it? It's around here somewhere. Come on. 207. 201. There we go. Is this the report? Where's the reference number? Where's the reference number, everybody? Wouldn't it be nice if these documents were config controlled and they had their own reference number, internal, external reference, so we knew exactly which documents we were referring to. So that's the chartering memo. For program investigations governed by that, establish an effective training protocol for those named to the investigation team to be completed at assignment to the team. Okay. Observation 4. There is no singular repository for pit final products. Okay. A repository of products would serve multiple functions such as educating new pits on style and expectations, enabling sharing of program lessons learned through the ability to query and browse a one-stop shop. Yes, that would be very helpful. So this really is talking about who or what is responsible for providing resources and making sure that they've got adequate, good investigators that are using the state-of-the-art methods that are, efficient and effective, and assessing new methods. And assessing new investigation analysis methods and safety engineering methods, and then sharing that experience. So who is there to broadcast that stuff? Who is sharing that? Because that's really who that recommendation needs to go to. So I'm assuming it's OSMA, which is it's not in the acronym list again. And I can't remember what it is. OSMA. Come on, what is it? It's not that one. No. Fantastic. Don't know what it is. If you know what OSMA is in the chat, please comment. Let me know, because I would love to know. Yeah, I don't know. Can't figure it out. Yeah, so enabling. Yeah, we talked about that. Right. So recommendations behind my head, so you can't see it. That's helpful, Simon. Well done. OSMA, create a consolidated pit product repository. The NTSB does quite a good job of that with their dockets for their investigations. It could be a bit better, but it is pretty good. I would recommend looking at that model. I think that would be helpful. Okay, right, where are we going now? So observation number 5. During crew flight test, leadership and team members who were not previously involved with or fully educated on the system being discussed caused frustration because of the perception of needing to educate these team members. Yeah, yeah. I completely understand that, and that is the case in pretty much every investigation or thing I've ever done in my career. And I think to some extent we have to remind ourselves to be humble. If you think about the population as a pyramid, where the bottom layer of the pyramid is the widest, they're the people that that are beginning. They're starting out. They have not much experience. They need the basics explaining to them. And especially if they've not been involved directly with this system, they might have been involved in something slightly different. So they need a bit of help to get over those stepping stones to cross that bridge. But that is part of the process. That is always going to be like that forever, unless you work in a very small community where the turnover of people is a lot smaller and everybody is an expert. Everybody's been there a long time and got a lot of experience. Me, myself, having worked across many different industries, predominantly aerospace and defence and complex systems development, tests and operations, once you've been through quite a few organisations, you know what the principles are. It's just you need the specific terminology or vocabulary explaining. When I went from aerospace and defence into submarines and submarine combat systems, that was the biggest delta change I've ever experienced, because it wasn't just the domain, maritime, submarines, Navy, Royal Navy, ballistic missiles, nuclear, reactors, torpedoes, all of that exciting stuff. It wasn't just the technology and the descriptions and how that all fit together and the documentation. It was also the organisation itself, because the organisations and the stakeholders involved in designing, developing, operating and creating those systems is complex, and you need to understand and get that knowledge in your head. And then the third is the information architecture and where that information is, and then of course how it's written, how things are described. Because in my experience, everybody has the same problems with system safety engineering and accident analysis. The only difference is the specific thing that you're looking at in that domain, and then the language and vocabulary and the concepts and the labels that those concepts have. Once you know how a fault tree works, you can apply it in any domain, so long as you've got that domain language and understanding. So yeah, this is just a common issue that is never going to be resolved. We just have to accept that. That's how it works. Okay, current NASA human spaceflight management in varying levels across multiple centres and headquarters primarily have low Earth orbit mission experience background Space Shuttle ISS. These are programs with traditional vehicle knowledge. I think that's really important to emphasize that. Or few primary providers. With Artemis operating in the lunar regime, there is a risk of low Earth orbit mental frameworks and system knowledge being incorrectly applied. Yes, that is absolutely a risk. Absolutely, that needs to be carefully managed, very carefully, because we're humans and we can say stuff when we're thinking something else. So what we're thinking is perfectly correct and valid, but what comes out of our mouth or out of our fingertips can often be incorrect. That's just the nature of being a human being, I'm afraid. And we can misremember things. So we have to develop discipline and due diligence and openness and being humble. If somebody challenges us or needs to challenge us, we should welcome that. And that's not an easy skill to develop, but it is possible. And it's even harder when things are stressful. Okay, right, what am I saying? So there is a risk. Yeah, so this here is absolutely needs to be dealt with, managed carefully. And it could be compounded by multiple providers and multiple vehicles of different type and function in a given scenario. Yes. So my suggestion, have a think about it through the lens of a control loop. So we're all human beings. We've only got so much mental capacity and memory and everything else. And if you're like me, things go in one ear and out the other quite quickly, unless you drill and practice and really embed it into your brain and rewire your brain, neuroplasticity. But if you're expected to have knowledge, mental models and beliefs about all of the different spacecraft designs, operational regimes, system architectures, you're just going to burn yourself out, blow your brains out. The principles, the architectures, the general physics of things, the general functions of things, everybody needs that common knowledge. But I believe you need a team that is aligned specifically to those different platforms, those different systems, those different operational regimes. You need to share that knowledge across the team. You need to resource your team to be able to do that. Because expecting individuals to have loads of knowledge and experience about current knowledge and experience of lots of different diverse systems is just it's ridiculous. So we have to design our organizations with that human mental capacity in mind. Because if we don't, you're going to burn your staff out, people are going to get stressed, and you're going to get accidents. You're going to put people at risk. So yeah, you could say that this is a, what do they call it? What was the term that was mentioned in Prague? Neuroergonomics or cognitive ergonomics. Cognitive system safety, neurocognitive system safety. So I'm going to do I've asked a professor from France who was in Prague at the European Stamp Workshop to do a podcast to talk about a similar topic. I'm not going to tell you the details now because I don't want to steal the thunder later on, but when I arrange the time to do that podcast with this other person, I'll bring this topic up because he knows a lot about this stuff. But essentially, we have to design our systems, our organizations with human factors in mind so that we're not purposefully design our systems with hotspots and the potential to burn people out, stress people out. We shouldn't be designing systems like that. It's ridiculous. And using the concept of a stamp control structure and a control loop can help us make those issues explicit so that we can carefully manage them. Yeah, okay, I've banged on that to death, so let's keep going. Excuse me. As risk discussions elevate, the need for educating a high leadership team may be imperative. No, it is. It is imperative. It's not. It may need to be. It is imperative. Strategizing how to do this pre-flight may alleviate trust eroding encounters during the mission. I would suggest that that is an absolute necessity. You know, if we are down here and this is our leadership team, we need to anticipate what decisions they're making, what beliefs they have, and anticipate what necessary feedback they're going to be, and the timeliness of it and the trustworthiness of it. And then also anticipate the control actions that are going to result, so that we can manage upwards in the structure. Fantastic. Okay, so we've got to observation 6. I think what I'm going to do is I'm going to take a quick 2-minute break, and then we'll carry right on with this. So please stick around, just bear with me for 2 minutes, and we will get right back on it. So just bear with me. I was quicker than I thought I was going to be. There we go. Right, let's get back stuck into it. Yeah, so as I was saying, we need to engineer our organisations with human factors principles in mind, because it's really not fair designing organisations that basically set people up to failure, stress, burnout, or worse. So I'm all for that, and we can use STPA to help with that. Like I said last live stream, every time I say STPA or control structure, you should probably have a shot. You won't last long. Anyway, right, let's have a look. So observation number 6. Oh, I'm busily talking away and you can't see what I'm doing. There we go. Look, I'm getting better at this. I actually remembered I needed to reshare my screen. There we go. I'm not muted, so that's good. I've not quite solved my inadvertent muting problem, but we'll get there one day. Right. Observation number 6. The propulsion system failures on the crewed flight test are significant and should be classified and documented according to the NASA mishap definitions and process NPR 8621. And if you remember from one of the very early live streams, I think we downloaded a copy of it, didn't we? Is it that one? 8621? There we go. So that's the NASA procedural requirements for mishap and close call reporting, investigating, and record keeping. There we go. The PIT has determined, so the PIT is the investigation team, has determined that the loss of 6 degrees of freedom control of the Starliner spacecraft during the CFT meets the criteria for a type A mishap under NPR 8621 Delta.1 Delta, the severity of the event, its potential for escalation, and its alignment with the definition of unexpected spacecraft departure from controlled flight. I'm going to have a go with that word in a minute. Warrant formal classification and documentation in the NASA Mishap Information System. Despite the significance of the event, it was not formally classified as a mishap or a high visibility close call. The decision, so let's just get our little jigsaw piece down here. So some controller in the senior levels in the program organization made a decision to not formally classify as a mishap or a high visibility close call. So the control action is the classification and the decision about what to classify it as. So why would it make sense for the controller, the decision maker, to classify it in the way that they did at the time? You know, what decisions were they making? What beliefs, what mental models did they have? What feedback did they have? Why would it make sense? You know, what was going on in their world to make sense not to formally classify it as a mishap or a high visibility close call? It says there the decision was criticised by multiple interviewees during the pit investigation who expressed concern that the absence of classification left a major safety event unrecorded in NASA's official mishap database. The pit concludes that this omission undermines institutional accountability and lessons learned. So the omission, you know, I said about the types of control action earlier on, omission is the control action is not provided. So we've got not provided, provided, time and duration sequence, and this is an omission type, so not control action not provided. So why would it make sense? What is it about this controller? What is it about the control loop? And what is it about the control structure around that controller that would contribute to that unsafe control action, contributory control action? Okay, so justification for a Type A classification. NPR 8621.1 Delta defines a Type A mishap to include unexpected. Oh yeah, sorry. Let me go back. I need to talk about this word here, and I'm going to get a different color so I could really emphasize it. Unexpected. Is that enough emphasis for you? Right. The definition of unexpected spacecraft departure from controlled flight. Based on everything we've sort of been through in these last 22 live streams and over 40 hours, I think now, of content, it shouldn't be unexpected that this happened. There were so many things, so many issues all over the place before they put the thing in space with people on board that we shouldn't be surprised we had a spacecraft departure from controlled flight. And so I would suggest, and this is a little recommendation from me, sat in my back cave in Salisbury, I would suggest that unexpected spacecraft departure from controlled flight, I think that word should be removed. Because it's whether it is expected or not. There's two questions there. The first is, let me get me a little jigsaw piece to really hit this point home. First off, who's the person, who is the stakeholder, who is the controller that we're implying exists that's interested in this? And their state of knowledge, their state of their process model, their beliefs, their mental model. Whether the spacecraft departure from controlled flight is unexpected or not is kind of irrelevant. What matters is whether the spacecraft is under control or not. If it's not adequately controlled, if the trajectory and flight path of that craft is not controlled or inadequately controlled, that is what we should be focusing on. And that is the prime sort of key core concept of what STAMP is all about. It's about adequate or inadequate control and making sure we control hazards. And if we can't control them, we control the response and recovery from those hazards. So I don't think the word unexpected should be in there. And I might sound like I'm being really pedantic, but what I'm describing is quite subtle and quite it's not that intuitive. I hope that makes sense. I'm not here to wordsmith things. I'm trying to boil things down to what are the basic essentials we need. And when we're talking about controlled flight, what are we actually talking about here? Inadequate control or controlled. Anyway, I'll get back off my high horse then. Let's keep talking. So justification for Type A classification, the process NPR 8621.1 Delta defines a Type A mishap to include unexpected aircraft or spacecraft departure from controlled flight. I think, what if you expect it to depart from controlled flight? What then? If you run out of fuel, or the part of the spacecraft's been blown off, does it anyway? Let's keep going. Unless such departures are pre-briefed or mitigated through the flight test process. Again, this makes the definition a bit complicated, doesn't it? While the thruster anomalies themselves may not independently constitute a mishap, the resulting loss of 6 degrees of freedom control represents a significant escalation in risk, should have led to the responsible NASA officials to declare a Type A mishap, and is the primary factor in the PITS assessment. Although the Crew Commercial Program references Revision B, oh, here we go, look. In the contract with the provider, which lacks the departure from controlled flight of spacecraft language, the current version, 1 Delta, takes precedence per another process. While the provider may not be required or obligated to use a version updated after their contract agreements, that does not stop NASA from performing its own evaluation based on the currently agreed to parameters and making a declaration. Okay, before I continue, I've encountered this problem in a similar context a number of times over the years, and quite often it's down to the way the contract is written and the way the program project managers interpret the contract and the implications of the documents they're talking about. So generally their view of the world is it's just documents, deliverables, activities, tasks and milestones. So they don't really know or care about what's in the documents or the implications they have. But it's important to understand that these documents, whilst they are just documents, they are kind of like a controller, because the content within them influences the decision making and behaviors of the people involved in the program that are subject to those documents. They give information to those people in those organizations, so if they read them and remember them, it updates their mental models and their beliefs based on what's in the document, and it should influence the decisions they're making and the actions they take. And of course, if those documents that provide inputs to these controllers, to these organizations, if those documents are not kept up to date, or new versions are not read and reviewed to understand the impact of those changes and then make necessary changes, or at least make sure the organization is aware of what those changes entail and whether they should consider making reasonable adjustments, unless that effort takes place, this kind of stuff is not going to be picked up. And it sounds to me like the senior leadership didn't define a Type A mishap because the documents that they're contracted to use and have available don't say to do that. So that would explain why it makes sense for them to behave that way. The separate conversation is about, well, what should the the contracts say about updates to certain documents, especially ones that involve safety and responding to incidents and accidents. I would argue that the contract should have a section in it, if not already, that refers to an appendix that is a list of, if any of these listed documents change, the program, the project, the operations must, within a certain time frame, assess and make appropriate changes. And of course, if the changes implied by those documents are significant, then of course there needs to be some kind of controller coordinating those changes and the agreements to it. And if they're not going to change anything, there needs to be a justification for that. And I'm not saying, I'm not picking on this particular program, because that is a common issue across every complex program since the very beginning of time. So, but the question boils down to, who is the controller of that? If there's an organization throwing a document over the fence to all of the suppliers, all of the operators, do they understand the impact of that change? Are they required to consider the impact and negotiate with those that they're impacting, or are they completely disconnected? I've seen that a number of times. In the UK defence context, we have the UK Defence Standard 00056, which is equivalent to MIL Standard 882, if you're familiar with that. And that document's been updated quite a few times over the years, and sometimes they go to the more prescriptive end of the spectrum, and then over a period of time they move back to the more goal-setting end of the spectrum. And of course, if you're working on a multi-year, multi-decade program, and they signed up to issue 2 in the 90s, and now we're at issue 8 or whatever it is in the 2020s, what are the safety teams supposed to do? What are the engineers supposed to do? Those criteria, those safety criteria, especially risk criteria, can evolve quite considerably. And it can start to raise some serious challenges in the programs and their safety cases, especially if we're talking about software safety. And actually, I'll go down this path now. If you introduce stamp STPA, we want everybody to do this, there's potential significant knock-on consequences and issues that are likely to arise that are then difficult, if not impossible, to deal with. And of course, there's a lot of stress there. There's a lot of potential pressure to try and suppress things. Because fundamentally, that's what this is all about. We're not going to look at the latest standard. We're going to put our fingers in their ears and put a blindfold on, because they don't want to know what the issues might be. And of course, they're not funded or resourced for it. They don't have the resources for it. And it probably wasn't in the original contract. So again, there's a recommendation there for making sure the contract covers these kind of changes and make sure that it's properly funded and resourced. Anyway, I'll get off my high horse again now. There we go. So we talked about, okay. So while the provider may not be required or obligated, I think that needs to be questioned. I'm not saying it needs to be, yes, they must be required and obligated. I'm not saying that. I'm saying that it should be considered and thought about, and agreements should be put in place and resources made available. That's what the contract should say. Because let's play devil's advocate a bit then. Let's say in a year's time, everyone's watched my videos, they love my videos, and they say, Simon, Stamp is amazing, CAST is amazing, STPA is amazing. We want to embed it in our processes, our contracts, and our providers, our suppliers, our subcontractors are really, really not happy to do that because they're scared of the cans of worms that it could open. And I can appreciate there might be certain systems, certain missions where if you open a can of worms, you've got to stop operating. I completely understand that. But there's a balance between not knowing and being ignorant and going and having a look and then mitigating the consequences, or at least trying to manage the risk as best you can. So which is it? Which path do you want to go down to oblivion? Would you rather know that there's an issue so you can at least try and plan for doing something about it? Or would you rather just not know and then, roll your dice and see what happens? I don't know. Is that a personal choice? Is that an organizational choice? Who gets to make that decision? Again, it goes back to this. Who or what is the controller that is empowered to make that decision? Turn a blind eye, forget about it, or lift the lid on the can of worms and deal with the consequences, or at least try to manage the consequences if you can. I don't know. I think that's it's a rhetorical question. It's not easy. It could be one way or the other. I think it'd be better if people were aware so they could manage things better and make decisions. That's what I think. More information, the better. Anyway, right. Yeah, so to use a version updated after their contract agreements, that does not stop NASA from performing its own evaluation based on the currently agreed to parameters and making a declaration. Yeah, it shouldn't do. Alternative classification for high visibility close call. Okay, troubleshooting during the rendezvous allowed for the spacecraft to regain control. Well, it got control, but we've got to think about whether we're actually in control or whether we have a perception of being in control. Because we can believe we're in control and we'll appear to be in control, but there could be other things at play. So we just have to be clear, what specifically are we talking about? Are we actually in control, or do we think we're in control? So mental models versus reality. And proceed into a safe docking. Again, we only know it's safe. Is that really the right word we should use there? I know I sound like a bit pedantic, but what I'm trying to implant into your brain is this critical control algorithm, critical mindset of when we're using these words, we need to be specific because we don't want to mislead ourselves. We don't want to be a bit laissez-faire and a bit relaxed. We want to be specific and disciplined. But also, who is listening to these words? Who is watching? Who is the audience? You know, we just have to be a bit specific, I think. Did we regain control in the truest form? Thinking about the control loop, were we directly in control or were we indirectly in control and our feedback indicated we had got control as opposed to we perceive we have? And we proceeded into a safe docking. So there's the question about the decision to dock. Was that a good decision? Was that a safe decision? It was obviously a risky decision. There's an element of risk involved in that. With hindsight that nothing serious happened, you could label it as a safe docking. But again, that's a decision to apply a label that's not necessarily, And again, it goes back to when we say safe, there's a spectrum of risk there. And where we draw the line of how we define safe is different between the stakeholders. There we go. Docking with ISS in auto control. Yeah, I mean, brave. This ability to regain the control, the ability to perceive that we've regained control, could be used as justification to assign the high visibility close call classification. Yeah, I can appreciate that, but again, it goes back to, do we actually know? Have we got clear direct evidence? Do we have direct control? Or is there some other layer of control between us and the spacecraft that could contribute to the same outcome? In fact, I'll emphasize that now, if you don't mind. Right. So imagine that this is the ground crew, ground control team making decisions about whether to dock or not. And so in this control path and this feedback path, there's a layer between there and there that is not emphasized in this little control loop. But between there and there is a whole layer of technology, communications, computers, hardware, software, everything. And then the physical movement of the spacecraft. And what it's saying up here is troubleshooting during the rendezvous allowed for the spacecraft to regain control and proceed into a safe docking with ISS in auto control. If we add detail to our little control loop, there we go. Let's put that there. So let's just add an extra layer in there, extra level of detail. This is our human ground controllers. This is the controller that does the auto function, the auto movement in rendezvous with the space station. How does the ground controllers know for certain that there aren't issues across this layer of the hierarchy, or in this layer of the hierarchy, in this layer of the hierarchy, or even this layer of the hierarchy? Because they might be perfectly fine up here, and from this perspective, that loop might be tickety-boo, no problems. But how do we assess, how do we gain feedback about this loop and whether it's actually working properly? You know, can we get adequate feedback to justify that decision? Is it engineered to be able to provide that feedback? Or are we just guessing, which, you know, in some cases is fine? Is it a gut feel? Or are we, you know, we're ignorant, we don't know. We haven't got the feedback and we don't know. Let me say that again. We haven't got the feedback and we don't know that we haven't got the feedback and that we need it. Unknown unknowns. You know, Donald Rumsfeld, if you look up his video from the first Gulf War, that's a good video about known unknowns and unknown unknowns. Anyway, let's keep going. So, supporting evidence. Yeah, that regain control and ability to regain is a perception. It is not necessarily fact unless there is direct evidence of that. You have to really trust that your layers of control between you, the human, and the end process is good and working and not going to misbehave or through failures or other systematic issues, non-failures that lead to the same outcome. Anyway, supporting evidence. While the pit was not chartered, oh, that's interesting. Pardon me. The pit was not chartered as a formal mishap investigation board. It was directed by SOMD. Oh, what are they called again? SOMD, there we go, Space Operations Mission Directorate. So let's put that over there. So we don't forget to follow most of the mishap process outlined. But also employ the guidance. Right, let me just use this so I remember. Employ the guidance in the program investigation team document. I think that's work instruction. I think we talked about it in the very early days of this review. The pit conducted a thorough, evidence-based investigation with the same diligence and integrity expected of a formal mishap investigation board. Question, Rocky question. Given that this was classified as a Type A or a Class A, whatever it is, where is it? Type A. Type A. Should it have had a formal mishap investigation board? And are they going to do one? Or is this it? The decision to not declare the event a mishap has broader cultural implications. It risks signalling a lack of confidence in NASA's established investigation process and may inadvertently undermine workforce trust in the agency's commitment to transparency and accountability. Yeah, that's an interesting point. But I'd argue that the decision not to declare the event a mishap. The question is, well, who is the decision maker for that? Who is the ultimate decision maker? Is it the CCP? Is it Boeing? Is it the operations team? Whoever it is, who is that? Are they formally given the responsibility and accountability to do that? And did they have the right decision making? You know, were they making the right decisions? Did they know what decisions to make? And what feedback did they have? It said earlier on that they were working to 1B, was it? Yeah, revision B. There we go. Look, everybody. So they were using revision B, and if revision B said, you know, these are it's different criteria, and they've not, you know, they've followed the process correctly. I'm assuming. I don't know, but let's say that they followed the process, and that process doesn't require them to, declare the event a mishap. Then that needs to be made explicit. There's a recommendation here that needs to be explored. Why did it make sense for them to make that decision? Was it because it was 1B instead of 1D? If it was supposed to be 1D, why was that not available? Why was that not mandated? What was going on there? The investigation should go and establish that, because it's important for this investigation, but also, like it says there, the broader cultural implications of it. And signalling lack of confidence in NASA's established mishap investigation processes. I mean, I haven't got the impression from what's said before that risk signals a lack of confidence in NASA's established mishap investigation process. But maybe there's something that you might be able to read between the lines. Maybe there's something else going on that's not stated yet. And when we get through the rest of the report, maybe that'll become apparent. And it may inadvertently undermine the workforce trust in the agency's commitment to transparency, accountability. Yes, I think that's also a factor. But I'd argue it's not just the workforce; it's the general general public. You know, humanity as a nation. As a global entity, if you like. We need to have confidence that the people involved in these high stakes, high risk, expensive things are actually doing things appropriately. And there is a level of perception, and then there's the reality, and it should be the reality that is perceived, not some saving face perception nonsense. Managing perceptions, that's the quickest way to destroy trust. But I understand the political dimension to it. But again, politics and safety engineering, safety management should be treated very carefully. Safety should win, except for very, very special circumstances. But that's a conversation for maybe another day in person. This approach also diminishes the perceived seriousness of the event, potentially confusing the workforce about the thresholds and expectations for formal mishap classification. Right. I would suggest that there is a question there about the control structure for the workforce. Are they given some basic training on what the mishap investigation process is, reporting, investigation? Do they have mandatory training? Maybe, 15 minutes as part of a yearly mandatory training. Hey, if you have any issues, you need to report it or investigate it. These are the procedures to follow. This is the latest one. This is where to find the latest one and previous versions. And this is what you need to know. So that they have their mental models updated, and so and their control algorithms, their decision making, so they know what to do if it's relevant to them. So I'd argue there's the safety information system, safety management system contribution here that we need to look at, maybe even a recommendation. Because they should know that. Everyone should know how to report an investigation and what's needed to do to contribute to an investigation if necessary. Especially for certain safety critical roles, certainly. The concurrent execution of the CCP STAR, SDRT, PIT, and the root cause and corrective action process introduced coordination challenges. All right, so I'm gonna just capture that, because I think one of the things to think about is when you're doing an investigation, what does the investigation control structure look like? And if you've got multiple investigation bodies getting involved, how do they coordinate with each other? And how do they coordinate, the information and the efforts that they're actually doing, so that they're not repeating things or missing things? So I'm just going to highlight these. So we've got the CCP STAR and the SDRT investigation. I can't spell. Then we've got the PIT, and I can't remember what PIT stands for. I'll figure it out later on. And then we've got the RCCA, Boeing RCCA, I think it is, if I remember correctly. RCCA investigation. And I can't spell investigation either. There we go. There we go. So let's put that one there, that one there, that one there. So if they are controllers, how do they interact with each other? How do we make sure that there's no gaps in the scope, or where there is an overlap, that it's properly coordinated? Okay, let's keep going. So the introduce coordination challenges, including overlapping. Oh, I just said that. Overlapping scopes, and occasional resistance to collaboration. That is an interesting one, because everyone's got their train sets, and everyone wants to play with our train sets, and they don't want other people interfering with it. That's important. These parallel efforts created the potential for missed opportunities. I can guarantee there are missed opportunities based on looking at this investigation report using STAMP. There are some big things missing, especially from an organisational perspective. In information sharing and subject matter expertise resource allocation utilisation, a key structural limitation was that, unlike a formal MIB, whose members are relieved of their normal duties. I don't want to read the next bit, because I've got a feeling it's going to say that these investigations were done in addition to the individual's day jobs. And if it does, I'm just going to be... Anyway, I'm anticipating what it says. Let's have a look. A formal MIB whose members are relieved of their normal duties to focus exclusively on the investigation. PIT members were expected to balance their participation with full-time responsibilities. Yeah. Well, I understand if you don't have many people, resources. I completely get that. But of an accident of this severity, somebody's got to call a pause in the program or in parts of it so it can be properly investigated and things dealt with. So I would like to understand, what is the control structure for setting up these investigation boards, for want of a better description, making decisions about who does what and how priorities are made. Who is the control that prioritise the PIT members to balance their participation with full-time responsibilities? Was that even a question? Was that even considered? Because it may be that, the PIT members are trying to do a good job and trying to do everything they possibly can and keep their full-time responsibilities going. But when you focus on something as intense as this, you need absolute clarity and focus. You can't have divided attention. It's like trying to drive two cars at once going in different directions. At some point you're going to smash into something and hurt somebody. So yeah, again, this is leadership. Who or what is the leader that made those decisions and made those priority calls, if the priority calls were made? And a recommendation for the future is the investigation board members must be relieved of duties, their normal duties, to be able to do the investigation. Now, I understand there's always going to be a balance and there's a grey area, but those decisions should be made before an investigation happens. That is a recommendation. This part-time engagement, and again, part-time engagement hampered the investigation schedule and further contributed to the perception that the effort was not being treated with the seriousness it warranted. Yeah, absolutely. That perception, that's a valid perception, I would think. If people are not prioritised to support this, then the perception is valid. That is the reality. They are not being prioritised. For whatever reason, there might be loads of valid reasons. I'm not criticising individuals here. The other thing as well, and a lot of people ask me about this when they're like, "Oh, Si, why should we use STAMP? Why should we use STPA? Why should we use CAST?" And I always say, the earlier you use it, the earlier you know there are problems and can then start dealing with them. The longer you delay, the more costly it is. So just, it costs X dollars, X pounds, whatever, to learn and start getting results with these methods. Invest that as soon as you possibly can, because the benefits from it vastly, like ridiculously disproportionate. And the sooner you do it, the better. You've not got opportunity lost. You've not lost the opportunity there. So the earlier you do it, the faster you do it, the better it is for everybody. The less disruption, the less costs. The longer you leave it, the more costly and painful it is. And of course, if you're doing an investigation, the evidence is not going to last forever. It's going to disappear. So you have to move fast. You can't be doing it part time. You need to get in there, get investigating, get your big questions answered so you can make recommendations for improvements. I mean, I would love to know why that was. Who or what is the controller that decided on the prioritization and coordination of these investigation boards? And it might be as simple, and I don't know, but my impression is it might literally be as simple as the leadership categorized this incident in accordance with that procedure version B, and it wasn't a big deal with those definitions. And then over time, people have been saying, hey, we think this is important. And so they've established these investigation boards, these groups to do the investigation. And then later on, it's been decided in accordance with the new procedure, the new version, actually, this is a really serious thing. And then instead of retooling or reorganizing, they've just carried on as they are and got to where they've got to. But again, this is a leadership issue. Who or what are the leaders involved in this? How did they make the decisions? And why is that not discussed in this report? Because I think that's an important topic. And again, if we think about the concept of the control structure, I always bang on about the design, development, test, and qualification control structure. Then you've got the operations control structure. And then you've got the emergency response and the investigation control structure. And all of this is pointing at who or what in the leadership of that response control structure has made these priority calls, if they were made. And depending which way that question is answered, will suggest which way the investigation needs to go and make recommendations for. I hope that makes sense. I'm sort of going on a bit there. Okay, and if nothing else, the discussion of shouldn't this be a mishap served as a significant distraction to the team, fielding questions and concerns regarding the authority and acceptance of the end product. Absolutely. And these are, these are very valid concerns. But again, who or what is the leadership for that investigation response control structure? Who was making those decisions? Because it would have been apparent from as soon as pulling that procedure off the intranet, looking at that criteria, it would have been apparent in seconds that this should have been a Cat A mishap, Type A mishap. And so that entity, that stakeholder, what did they do next? Were they in a position, did they have the responsibility and authority to say, look, I don't really care what the program says. This is what we're classifying at. This is the response we need to have. And the program needs to step in line with that. And then the issues with whether they were using an early version because of contractual reasons or not can be sorted out in slow time. In fact, there should be a recommendation in here that says they need to go and understand why that was not recognised and get the contract changed if the contract needs changing. And I know that's easy to say. I recognise that, but that is necessary. That needs to be considered. Okay, right. Additionally, NPR 8621, which version, come on, be clear in your referencing, allows for a mishap or a HVCC to be classified per the NPR, but utilise an approve alternative investigation strategy. What does HVCC stands for, everybody? Let's have a look. Is it in the acronym list? No, it is. Yeah, look at that. Way. It is. Look at that. Fantastic. Duplicate HVCC. High visibility close call. There we go. Right, so additionally, the process allows for a mishap or HVCC, high visibility close call, to be classified per the NPR, but utilize an appropriate alternative investigation strategy. Okay, so is it utilize and approve, or an approved alternate investigation strategy if the NPR requirements were met? Knowing that every anomaly investigation faces its own challenges and nuanced consideration, it stands to reason that an event could be classified as a mishap or an HVCC and also utilise the more local PIT process. This includes many of the advantages that were sought in standing up this Starliner prop PIT in looking for a team that was already educated to some degree on the anomalies and could take minimal time to get up and running in the investigation. Without formal classification, this event is not entered into the NMIS, which is the NASA Mishap Information System, I think, from the other page. There is no requirement for a cap. What's a cap? Cap. It's not in there. With defined actions, timelines, and verification and closure. Transparency, trust, and institutional learning are compromised. Yes, I completely agree with that. Recommendation: given the severity of the event and its alignment with the Type A mishap definition, the PIT recommends that the event be formally classified as Type A. When it says it recommends, I would love to know who it's recommending this to. Who is the stakeholder? Let's look at our control loop. So if this is the event, this is the investigation, this is the PIT team, the investigation team, and then there are the other two investigations as well. And they provide feedback, recommendations to a stakeholder. Who is that? Is that the head of NASA? Is that head of the crew commercial program? Is it Boeing? Who is it? Who is that stakeholder? And should it be a recommendation to them? Because they could just say, no, we're not doing that. Yeah, we don't feel like doing that. Or they might say, yeah, do everything. You know, who is that? Is it not the investigation team that recommend or mandate? Are there things that should be mandated, or is it some other decision maker? Who is that? What is that stakeholder? Let's make it explicit. The event be formally classified as a Type A mishap. Yeah, fantastic. If it was me, I would put inside their reference under what criteria, specific reference we're talking about. Because just saying classified as a Type A mishap, you know, if it's in accordance with reference version 2 instead of version 4, it could be a different definition. So we need to be clear on that. The event be monitored in the NASA Mishap Information System to ensure institutional learning and accountability. Again, if you put stuff in there, how does it actually get down to people? You know, if this is the NMIS and we stick stuff in there, how does it actually get down to the people that will benefit from it? Is it a control action, or is it information only? Or are we expecting them to go and look at this stuff? Is there a mandatory requirement for that? Is there a layer between the NMIS and the specific program that's looking at the context of the NMIS and then communicating to the program? In a nutshell, this is what you need to know for your context based on what's in the NMIS. Does that make sense? Yeah, anyway. The PIT be considered the investigative authority for this mishap, and the report should be considered. No, sorry, mate, I don't agree. Do not stand up and no, I don't. No, sorry, I don't agree with that. Do not stand up another investigation team or an MIB. No disrespect for the team doing the PIT or the RCCA or the other one, but this investigation does not go far enough. It's relatively limited from what I've seen so far on the technical layer. the equipment system itself. It mentions bits about qualification and testing and leadership and all of these other good stuff, but it doesn't actually go in there and dig in and have a look at it. And you'll see from all the live streams I've been doing that, I've made loads of recommendations myself, and I think I'm going to have a job trying to write them all up. I think I'm going to have to, get an AI or something to watch all my videos and summarize it for me, because there's so much of it. But it doesn't go far enough. It doesn't ask the questions that are necessary, and it doesn't make the recommendations I would suggest. Now, of course, maybe I am being unfair because they've not used STAMP, STPA, or CAST to help shape the investigation and the questions that they've asked and the topics that they explore. I totally get that. But I'm hoping that you seeing these videos and taking part in the live workshop, you'll be like, well, they need an investigation team equipped with STAMP, STPA, and CAST to go and deal with all of this stuff. Take the themes that are mentioned in this investigation report and just go further. And when I say go further, I don't mean go further on everything just because you can. I mean, be strategic. What are the parts of the control structure we need to focus our effort on? Let's be strategic about it. Let's be strategic about the type of recommendations we're going to make, and then also consider the tactical implications of those recommendations. Because as I say, you don't just make generic recommendations that are they're kind of obvious, they're kind of trivial. It's like, well, I could have probably written those recommendations without doing the investigation and writing it down in a big report. But CAST, STPA, and STAMP allow you to go much further than that and be very much more specific. And I'm not saying it's easy. It can be quite painful, especially when you're dealing with, very sensitive topics or where there's a lot of, politics or whatnot. But that's, if you want to get the answers and you want to make this thing better, safer, less costly, then it's necessary to suffer that pain up front. Let's do the work. Let's not be afraid to do the work. Like I said earlier on, I think Ryan Holiday's book on Stoic philosophy, the obstacle is the way. This is one of those circumstances. And I'll just get off my high horse again. I'm shouting into the screen. I'm sorry. Anyway, I'm passionate about this. My vision for the future is that STAMP becomes mainstream and becomes one of the core processes for systems engineering, safety engineering, and then in the context of CAST for accident investigation, incident investigation. Because I firmly believe it's going to be, it's going to be revolutionary for where we are today. And I am hoping that some of the things you've seen, maybe some of the short videos that I've put out, and I still cringe over those, but I've got to put things out there. I think it is going to make a huge difference. It's going to make a huge positive difference. But we've got such a long way to go. And if you can help with that, or if you want help, please don't hesitate to reach out. Okay, so the PIT's recommendations follow the formal review, approval, closure, and verification as required under that process 8621.delta 1 delta. In the future, consider separate actions for assigning classification and specifying investigative approach. Depending on the severity, seriousness of the anomaly, investigation leadership should consider dedicated full-time investigation teams without the need to fulfill the duties of their assigned role during the investigation. I don't think it's up for consideration. I think you need SMEs and dedicated investigators, dedicated accident analysts, and then they come together and work together to go through the investigation. If something, we're talking in the range of billions and billions of dollars and pounds. This is not small fry. This is not investigating slips, trips, and falls in the local factory. This is big stuff. We should take it seriously and resource it seriously. I'm preaching to the choir. Without the need to fulfill the duties of their assigned role during the investigation. Yeah, absolutely. Right. So we've got through additional observations. So we've done that. So let's mark it off on the screen. Here we go. This is a little thing I do just to keep me motivated. You know, just mark off what you've done. Yay! We've made some progress. We're getting there. We're I think we're all no, we're not halfway. I think it's a 312 11-page document. 311, and we're now at 151. So we're not quite halfway. But trust me, the next sections are not going to take as long as this. Some sections will, but the majority are quick to fly through because most of it's redacted. So anyway, as I was saying, if you need some help and support, if you've been watching these videos and you're like, actually, Simon, this sounds like it could really help us, and you want some help and support, visit my website, whiteley-safety.co.uk. Click on the green button. I'll get that right one day. This button. Click on the button. Send me a message via the contact form. We can set up a conversation. No obligation. It's not all about the money. It's about making systems safer. That's what it's all about. We can have a conversation. And honestly, if you do need my help and you need me to get on a plane in the middle of the night, I'm happy to do that, to come and sort these things out. After reading the stuff I've just read today, I'm absolutely convinced we could do so many fantastic things with this program and these methods. So if you need that help, then let me know. And like I said, all of this is aimed to doing a free workshop. So if you want to just, if you don't want to have a conversation, you just want to get on the workshop, go to the website, click on the link, stick your name in there, join the wait list, and then when I've done everything I need to do, I'll send an email out. We'll get together on Zoom, get the cameras on, and we'll have a good chat about this and answer any questions you've got. So yeah, I'll set the dates for the next live stream. I think we're going to need another probably 4 or 5, let's say 10 hours worth of effort to get through the rest of it at the current rate. So maybe next week, maybe the week after, we'll finish that. And then I'll be able to do the case study and then set up the free workshop. So yeah, watch out for the LinkedIn events, or if you are not a subscriber of my YouTube channel, why not? Go and subscribe right now, do some likes, do some comments. Subscribe to the YouTube channel and then you'll see the notification for when the next live stream goes live. Otherwise, the LinkedIn events, you can actually click attend and it should notify you when I go live, and you can come and join me, give me some abuse in the comments, in the chat, and we'll all generally have a good time. So yeah, with all that said, thank you very much for watching my live stream number 23. I'm doing this for the passion. I hope you're passionate too, and I really want to contribute to the community. But thank you for your attention. Have a great weekend, and I will see you on the next live stream next week. Take care. Bye-bye.